Spring 1886. The northern plains of the Dakota Territory were still raw and unforgiving. 12 miles south of what would one day become Bismarck, the Cannonball River Valley stretched wide and quiet, grassland broken only by wind, sky, and the slow work of homesteaders trying to survive a place that showed no mercy to mistakes. That spring, one man announced a plan so strange it stopped conversations mid-sentence. A German immigrant named Friedrich Weber told his neighbors he was going to dig a barn into the hillside, directly beneath his house. Not beside it. Not behind it. Under it. In a territory where one bad winter could erase a decade of work, most people didn't see innovation. They saw catastrophe waiting to happen. The first to say it openly was Thomas Fletcher, a cattleman running more than 200 head and widely considered the most experienced stockman in the valley. "Friedrich," he said flatly, "you're planning to stable horses under your living room. That's not ranching. That's inviting disaster." Fletcher ticked off the problems one by one. The smell alone would drive the family out. If the ceiling failed, man and livestock would be crushed together. And if fire or panic broke out underground, there'd be no escape. Others agreed. Underground barns weren't just unusual, they violated everything frontier builders believed about safety. But Friedrich didn't argue. He listened, nodded, and kept measuring the slope of his land. Because to him this wasn't madness. It was memory. He had grown up in the Black Forest region of Germany, where his grandfather ran a small dairy built into a hillside. The animals lived below, partially buried in earth and stone. The family lived above. It wasn't common, but it worked. In winter, the animals' body heat rose through the floor, warming the living space. The surrounding earth held a steady temperature year-round, cool in summer, insulated in winter. And when storms rolled down from the mountains, the structure didn't shake, burn, or collapse. It sat protected beneath tons of soil and stone. What Friedrich saw as proven design, his neighbors saw as reckless experimentation. He had chosen his claim carefully. The land featured a south-facing hillside that rose about 20 feet over 60, a long, gradual slope, not a cliff. The top was flat enough for a house. The face could be excavated cleanly. That geometry mattered. By digging straight into the hillside, Friedrich could create a barn entrance at ground level on the downhill side, while the space itself extended deep beneath the house above. No ramps. No stairs. No lifting animals underground. Just gravity, earth, and careful planning. If you're here because you respect the ingenuity of people who looked at land and saw solutions instead of limits, this channel is for you. These are the ideas that kept families alive when failure meant losing everything. His plan was precise. He would excavate a space 40 feet deep, 24 feet wide, and 8 feet high, a massive cavity carved by hand. The ceiling would become the floor of the house above. The walls would be compacted earth, reinforced with timber framing and stone where needed. The entrance would face south, shielded from the brutal north winds. Inside, he planned to stable 8 horses with room for hay and equipment. His wife, Margaret, studied the sketches one evening by lamplight. She understood the logic, but she also understood the risk. "The horses will be warm," she said quietly, "and their heat will rise to us. But Friedrich, if something goes wrong, if water seeps in, if the ceiling fails, we lose everything at once." He didn't deny it. "Yes," he said. "But if I build it right, none of that will happen. And if winter comes like it did in 80 or 81, surface barns fail." You've seen it. Everyone had. Thomas Fletcher had lost 40 cattle when his barn roof collapsed under snow. John Morrison lost 60 when a lantern fire took his structure in minutes. Henry Schultz lost 30 when walls failed during a 3-day windstorm. An underground barn couldn't burn. It couldn't blow over. And snow couldn't crush what snow never touched. Not everyone opposed him outright. Catherine Martinez, whose family had ranched the valley for a generation, offered a more traditional view. "My father built thick walls and deep foundations," she said, watching Friedrich mark the hillside. "His barns have survived every storm. You don't need to dig like a badger. You just need to build solid." Friedrich nodded. "Your father's barns are excellent. But they require lumber I can't afford, and labor I don't have. I'm one man with a shovel. Earth is free." That answer unsettled people more than his plan. Then came the harshest criticism, from Samuel Brooks, a veteran builder who'd worked across 3 territories. "You're talking about digging 8 feet down and placing your house on that ceiling," Brooks said. "The load requirements are enormous. You need support timbers every 3 feet. One failure and the whole thing comes down." "Then I'll timber every 2 feet," Friedrich replied calmly. "And I'll oversize every post. Even if 2 fail, the rest will hold." You're not an engineer. No, Friedrich said. But I can calculate weight. I can observe what holds and what breaks. And I can build stronger than necessary, because the cost of failure is too high. Construction began in June. Friedrich cut into the hillside one shovel at a time. Dakota summers reached 95 degrees and he worked from dawn until mid-morning, rested through the heat, then returned until dark. Margaret and their two sons, Johann, 12, and Klaus, 9, hauled earth away in a hand-built cart, spreading it to level the ground near the house site. After 2 weeks, the outline emerged, a rectangular cavity carved into the hill. The entrance at ground level on the south side. The space tunneling 40 feet inward. And 20 feet upslope, the future house, its floor destined to sit directly above 2/3 of the underground barn. Thomas Fletcher rode by often. One afternoon in July he looked down at the excavation and shook his head. "You've dug a hole," he said. "A mighty big one. But I still don't see how this becomes a barn." Friedrich didn't answer. "You just kept digging. How are you going to roof it? How will you keep it from flooding? And how do you expect horses to walk underground?" The questions followed Friedrich every time someone rode past the site. Animals weren't stupid, they said. Caves and holes were where predators waited. No horse with sense would willingly walk into the earth. One afternoon, Friedrich finally paused his digging. He leaned on his shovel, wiped the sweat from his brow, and answered calmly. "The roof is earth and my house floor," he said. "The drainage is a trench around the perimeter, feeding into a sump on the low side. And horses go where they're led. If they trust the person leading them, and if the space feels safe, I'll make it safe." By August, the excavation was complete. What remained was the most critical phase: structural support. Friedrich hauled straight cottonwood trunks from the river valley, each 12 inches in diameter, cut and trimmed to 8-foot lengths. These would become the vertical posts. He set them into the earth floor in a precise grid, every 2 feet, rising to meet the future ceiling above. 64 posts in total. Each one was capable of bearing several tons of vertical load. The design was intentional redundancy. Even if 5 posts failed, 59 would still hold. This wasn't gambling. It was over-engineering, because underground construction forgave nothing. When Samuel Brooks came to inspect the work, he stopped short. "You've built a forest in here," he said, walking between the posts. "I'll grant you this: if the ceiling falls, it won't be because the posts failed. But you still need ceiling beams. 30, maybe 40 of them. Each one carrying the weight of the house above. Where are you getting that timber?" "I'm milling it," Friedrich said. Using a whip saw, he and his son Johann began converting logs into rough-hewn beams, 8 inches square. It was slow, brutal work. A full day of sawing produced only 3 usable beams. But each one was sized for the load it would carry. By September, the ceiling began to take shape. Primary beams spanned from post to post, forming a rigid grid. Smaller joists ran perpendicular across them. Then came tightly fitted planking. Over that, canvas soaked in tar for waterproofing. On top of that, a layer of packed clay. Finally, Friedrich backfilled the entire structure with 18 inches of compacted earth, laid in 6-inch layers. The result was a ceiling that could support the weight of the house, everything inside it, snow load on the roof above, and still have a safety margin measured in thousands of pounds. When it was finished, Friedrich walked across it with Johann and Klaus. No flex. No creak. It felt solid, like bedrock. The walls came next. Though the surrounding earth was stable, Friedrich added retaining structures. Vertical posts every 4 feet, horizontal planking behind them, and stone backfill where gaps appeared. These walls weren't load-bearing, the earth itself carried the weight. Their purpose was control, stability, and longevity. At the entrance, he framed a 12-foot wide opening on the south face of the hill, supported by heavy timbers and a massive header beam. Large wooden doors could close it if needed, but most days it remained open for light and airflow. A gentle ramp descended from ground level, dropping 3 feet over 12, easy for horses to navigate. Inside, Friedrich laid out the barn with precision. 8 box stalls lined the north wall, each 8 by 8 feet. Timber partitions stood 4 feet high, with open gaps above for airflow. Along the south wall, raised hay storage kept feed dry and off the ground. A wide central aisle ran the full length of the barn, allowing space to work and move animals safely. The floor was a problem Friedrich refused to ignore. Bare earth would turn to mud. Instead, he laid a base of stone, covered it with sand, then installed tightly fitted wooden planks. Liquid waste drained through the seams into the sand and stone below, slowly percolating away. Solid waste would be removed daily. It wasn't perfect, but it was functional. Ventilation was the final challenge. 8 horses underground meant heat, moisture, and risk. Friedrich installed 4 ventilation shafts, each 8 inches in diameter, made from rolled tin. They rose from the barn ceiling, passed through the earth and house floor, and exited at the roof above. 2 shafts drew in fresh air near the entrance. 2 vented warm, moist air from the rear of the barn. No fans. No moving parts. Just physics. By October, the barn was ready. The horses hesitated at the entrance, just as skeptics predicted. But Friedrich led them in one by one, calm and patient. Within an hour, all 8 were inside eating hay, settling into their stalls. That evening, Margaret walked down the ramp. "It's warmer than I expected," she said. Outside, the temperature had dropped to 42 degrees. Inside the barn, it held steady at 54. "The earth stays near 50 year-round," Friedrich explained. "The horses add heat. Winter will make the difference even clearer." The house went up in November. Modest, 20 by 30 feet, built directly atop the barn ceiling. Heat from the animals below rose through the floor. The family needed only a small stove for cooking in the coldest nights. Their fuel use was a fraction of their neighbors. When Catherine Martinez visited later that month, she was stunned. "It's dry. Clean. The air moves. The horses look healthy. And your house is warm," she said. "I thought this was madness. I was wrong." "It's old engineering," Friedrich replied. "Applied correctly." December brought the first test. A week below zero. Surface barns struggled. Fires burned day and night. Water froze. Horses needed extra feed just to survive. Friedrich burned nothing. The barn stayed between 48 and 52 degrees. Then came January 1887. The storm remembered across Dakota Territory as the Death Storm. Temperatures plunged to minus 43 degrees Fahrenheit. Winds exceeded 60 miles per hour. Snow piled 15 to 20 feet deep. Livestock froze standing in open fields. Barns collapsed. Fires failed. Thomas Fletcher lost 23 horses when his roof gave way. Catherine Martinez's family lost cattle despite burning every stick of wood they had. Samuel Brooks lost his workshop, and nearly his life. Later calculations would show it endured more than 6,000 pounds per square yard, combining the weight of the house, heavy snow load, and ice accumulation. Not a single timber cracked. Not one post shifted. Above it all, Friedrich's family stayed warm through the entire 4-day storm with a fire that consumed less than a single cord of wood. Heat rising from below, combined with snow packed thick around and on top of the house, created natural insulation. The storm that destroyed surface buildings became part of the system. Another protective layer. Every 6 hours, Friedrich checked the barn. He didn't go outside. Instead, he descended through a trapdoor cut directly into the house floor, an access point he had installed specifically for emergencies. Moments when drifting snow could seal the exterior entrance completely. Below, the horses stood calm. Breathing steady. Water unfrozen. Hay dry. When the storm finally broke on January 13th, Friedrich dug out the south-facing entrance. It took 4 hours to clear a drift 12 feet deep. When daylight poured in and the doors opened, 8 horses walked out into the sunlight, healthy, alert, unchanged by the disaster that had just swept the territory. Across the valley, ranchers were doing the opposite. He explained the 8 feet of earth on 3 sides. The 20 feet of soil above acting as thermal mass. The body heat of the animals trapped instead of lost. The redundant structure that made collapse mathematically improbable. The south-facing entrance, protected from wind and always diggable. The ventilation system, passive and shielded, that never stopped working. Thomas listened. Then he said quietly, "I mocked this. I called it madness. I was wrong. My horses died because I trusted tradition. Yours lived because you trusted calculation." Then he added the sentence that would be repeated for years afterward. "Sometimes the best protection isn't building up. It's going down." Word spread. In March, Samuel Brooks returned, this time with a notebook. Clients whose barns had failed were asking him about underground options. "I need the load calculations," he said. "Post spacing. Timber sizing. Vent placement. I told people this was foolish. Now they want me to build it, and I need to do it safely." Friedrich spent 3 days teaching him. Not measurements alone but principles. Why redundancy mattered. How loads distributed. Why ventilation had to move air without relying on exposed mechanisms. Why drainage mattered more underground than anywhere else. "This should be standard practice here," Samuel said when he left. "Every rancher should have the option. In April, Catherine Martinez brought her father. The old rancher moved slowly through the space, testing timbers with his hands, studying the ceiling. In my country, he said, old Spanish land grants had structures like this, not for horses but for storage. Cool in summer. Stable in winter. Same principle. He nodded. I'd forgotten this. By fall of 1887, 4 ranches in the Cannonball River Valley were building underground or partially underground barns. None were identical. Each adapted the idea to local land. One rancher built into a west-facing slope, half buried, half exposed. Another, a Norwegian immigrant, constructed a fully underground stable disguised behind a conventional barn facade to control drifting snow. The principle spread beyond the valley. Near Fort Abraham Lincoln, a rancher built underground stables for mule teams. In Bismarck, a merchant created an underground warehouse that maintained stable temperatures year-round. The Territorial Agricultural Office documented the design and circulated it as guidance for cold climate livestock management. What Friedrich had done wasn't invention. It was adaptation. Earth-sheltered structures had existed for centuries across Europe. What Friedrich recognized was that this ancient knowledge solved frontier problems perfectly. Limited lumber, extreme cold, catastrophic storms, and the high cost of heating large spaces. Modern agricultural engineering would later confirm what Friedrich proved through experience. At depths of 6 to 8 feet, Earth maintains stable temperatures year-round, typically between 45 and 55 degrees Fahrenheit, reducing energy needs and animal stress. Redundant supports, distributed load, and passive ventilation are now standard in underground construction. Friedrich's barn served his family for 32 years. He expanded it twice, once in 1889, again in 1895. His sons both became ranchers. Both built earth-sheltered barns. Both survived the brutal winter of 1896 to 97 with minimal losses while conventional barns failed. Friedrich died in 1918 after more than 3 decades on the land. The barn outlived him. It remained in use until 1954, when the property changed hands and modern facilities were built. The entrance was filled in. The structure left buried beneath the hillside. Still intact. In 2009, a researcher studying frontier architecture uncovered Friedrich's original plans in a county archive. The drawings included load calculations, ventilation diagrams, and notes on animal behavior underground. When compared to modern engineering standards, Friedrich's calculations were within 5% of current specifications. The lesson is consistent. Survival favors those willing to look beyond convention. Friedrich saw a hillside and recognized protection. He trusted physics over tradition. He accepted mockery because the math made sense. When the storm came, the kind that kills thousands, his willingness to think differently made the difference between loss and survival. The underground barn is gone. The wisdom remains. Sometimes the safest shelter is underground. Sometimes ancient techniques solve modern problems. Sometimes the people laughing are the ones who haven't done the calculations. Friedrich built down when everyone told him to build up. The Dakota winter settled the argument. When your neighbor's horses freeze and yours walk out healthy, the lesson doesn't need defending, it speaks for itself. Inside Friedrich's underground barn, the temperature never fell below 46 degrees. The horses stood calm. Water stayed liquid. Hay stayed dry. The storm raged overhead, but underground life continued. When it ended, the valley looked different. So did the way people thought about building.